but I've been pretty good about making the recordings. Let's take a look at these. Now, whether you did this or not, make sure you can do this. If you weren't here, we said these work very differently because the basic reason is we have a restriction in the denominator. We have a domain restriction, which means I can't make a continuous curve anymore if there's certain numbers that I can't use. I'm going to have to jump over them. So we find first your domain. Then after factoring, and you weren't going to be able to factor any of yours, factor and reduce. After we factor and reduce, we'll look for our, what's left in the domain, what's left in the denominator, will become an asymptote, a vertical asymptote. That's the one you can never cross because that comes from your domain. So if I can't use a zero, it's going to give me a line here called an asymptote. And what's nice about this is it guides the ends. Instead of being a cubic function and the end is down and up, or a squaring function and they're both up, this one's going to be guided by the asymptotes because they're going to have to jump over certain values that they can't use. We have 3 rules to find your horizontal asymptote. We find your x-intercept, we find your y-intercept. We always find intercepts. We do max and mins, and in this case, there is no max and mins. P.S. Your calculators sometimes do a real bad job at this. If, for instance, here's my asymptote here, and here's my asymptote on my axes, so a lot of times, not in this case, but a lot of times what happens is this. It goes to draw it, and it looks like it stops. It doesn't stop. Look at your values in your table. It rides along this and gets as close to that axis as possible. So your y value is constantly decreasing. Sometimes in the table you can't even notice it because they round. For you to notice it, you got to scroll over to your y, and you got to see it move. Okay? It's ever so slightly. The same thing when it comes this way. Sometimes it looks like it stops, but it doesn't. It rides that axis forever. So there's no max and there's no mins when it does this. There is, however, we do consider this a cave up. We do consider this a cave down. Even though we're not actually making that big curve, we consider this a cave up and we consider that a cave down. The best thing to do is sit with that sheet, Monica.
I had a hard time with some of the sketching like the graphs.
Right.
Because like since I'm not using like one of these type of
Right.
calculators, it doesn't like show the
Right. So this is what you're going to do. Get a little bit of a picture from your calculator, and then do this. As soon as we make our asymptotes, start like this. My asymptote says my vertical asymptote is my y-axis, this guy. Start like this. My horizontal asymptote, y equals -1. Now, you know, in your calculator, you saw something up there in the right-hand side, right? Well, you're going to use your asymptotes to help guide you. So your asymptotes are going to go like, your asymptotes are going to be something you're not going to get through. So it's going to just ride this and go like this. Then I saw something down here. So it's got to come from here and just go like this. That's all you have to give me for a sketch. Even with the yellow ones, I don't think they're as sharp either. The only ones that do a really nice job are the color ones. Anybody have a color one in here? Nobody has a color one? Not the color ones actually. What's nice is like when you have something riding along here, because our lines are black on the calculators and they're also black on the line itself. The color ones will have a blue and it'll ride right over that axis. The color ones do a wonderful job with it. Our regular ones is black on black. You really can't see anything. You can't see it sitting there. You got to look in your table. Was that a little bit more helpful? Do your asymptotes first, and then you do your sketch. I find that to be more helpful. Okay. All right, now this guy has a little bit of a problem with the negative out front. If you just did your zeros of your numerator, and you just did your horizontal asymptote, You forgot about that little negative out there. So my advice is just distribute that negative. I could write a number like this. But somebody has to get assigned that negative. Because if it's sitting out here and you just deal with this part, you've eliminated your negative. So either distribute it to your numerator or your denominator. Chances are it's so much better in your numerator. So distribute that to your numerator. Put it up here. But remember, not just to the first term, to the whole numerator. So your numerator is going to turn into this. So if you didn't see that part last night, sketch this in your calculator. And this is one of those times, can everybody find their fraction bar? If you're on the black calculators, you don't have a fraction bar. If you're on the yellow calculators, alpha, y equal. God bless you. As a matter of fact, did somebody kind of by accident take a calculator home? After you guys left here, one of my calculators was missing. Yeah, but I know one had to come from this group. Just check your backpacks. I mean, that's a normal thing. Everybody slides it in. My other one has never been returned. I don't know what happened to it.
Wait, what are we looking for?
You're looking for alpha y equals,
And then put it into fraction.
and then you're putting it into your fraction. Just hit enter and put that in. Otherwise, you know you have to put in parentheses around the numerator, parentheses around the denominator. So I start again with my asymptotes, and my asymptotes again, and then I sketch my graph. Now, there are times when a function will jump over a horizontal asymptote, but never, never a vertical. Sometimes a function can come down here, jump over this, and come back up. Very, very, usually jumps over at axes. But it could jump over it, and then right alongside, it'll jump over it, and then use it as a, use it here. That's a really Corvette, the way I did it. Get rid of that. Here's your axes. Your function could actually come like this, jump over it, and then still use this as end behavior. I don't really do that in here with you guys, but it could happen. In that case, you get a min or a max, whichever way it's facing. This one would give you a min. If it was above, it would give you a max. But it could cross a horizontal. It can never, never, never cross a vertical. Because a vertical is a denominator restriction. Again, your y-intercepts, there's no max and mins, and your concavities. Your y-intercepts, go back to your original problem and just take out the x's and work the y-intercept real, real simple before you even factor anything. And your x-intercept, set your y equal to 0 in your numerators. It's the numerator. And that's after we factor, but today we're going to hit a factoring part. Okay. 3, that should have been a nice one. Is that a nice one to do? That should have been an easy one. You got a little increasing part, you got a little decreasing part. Your concavity is real straightforward. Your degree in your numerator was less than a degree in the denominator. You can almost see the y equals 0, the x-axis. It's never going down below it. You have only one thing in the denominator, which is a 0 that you can't use. No inflection points. We have no turns. Because it's not continuous, so we don't have to worry about that. Any questions? Did we do 4 together?
No, we did 5 together.
5. Okay, so 4 was the last one that you did. Again, that's a double root down on the bottom there. But just do it once. You're fine.
Wait, that's not.
Not a double root, a double factor. Oh, sorry, a triple factor. Just do it once. There's your denominator restriction. You got to write it 3 times. It's a cubing thing. But just set it equal to 0. It's because if you took the cube root of 0, it's 0. So just do it once, set it equal to 0. Horizontal asymptote, vertical asymptote. That'll help you graph it. Both of those sections are decreasing. Let's put this in your calculator. Yes.
When you press the record button on there, does it stop recording what you write down or just like no, you press it, so I'm saying
You have an idea of how this goes?
Yeah.
Okay, now, yes.
I don't have this paper.
The one I just handed out?
I only have
Okay. Okay, so now, let's start with this. Do we have a domain restriction problem? Yes. What number can we not, what value can we not use? 2. So let's take the domain. Let's take 2 out of our allowable domain. We're just going to jump over the 2. We can't do our range to the entities because we need to know if we have a maximum, a horizontal asymptote, whatever we're missing here. So now, we're going to find our asymptotes. Can we factor this guy? No? Not factorable and reducible, so we don't have to worry about that. So let's hit our vertical asymptote. We look at our denominator, same as our domain restriction. Okay? Let's look at our horizontal asymptote. Horizontal asymptote says, find me the highest exponent in the numerator, the highest exponent in the denominator, and compare them. If the one in the numerator is less than the one in the denominator, if the one in the numerator is equal to the one in the denominator, we don't have either one of those cases. If the one in the numerator is greater than the one in the denominator, that's our case, we have no horizontal asymptote. The degree in the numerator is greater than the degree in the denominator. Now, jump down to the word slant asymptote. It's on that sheet close to the bottom. A slant asymptote says if the degree in the numerator is exactly 1 more than the degree in the denominator, then I have a slant asymptote. So this guy has a 2 over a 1 is exactly 1 more than the denominator. So I have a slant asymptote. Now my slant asymptote says, okay, in order to find it, I'm going to do synthetic division. I'm going to take my coefficients out of my numerator, 1, -2, 4. I'm going to divide by my 0, and what would it be? 2. I'm going to bring this down. It's kind of nice because we don't really care about the remainder part, but we're going to do this part. We bring this down. We have a remainder of 4. Cross out your remainder. I don't care about the remainder. So now I say x2 over x1. What am I going to start with? X. This is y is equal to 1x. Or just plain old y is equal to x. There's my slant asymptote. Drop the remainder. Let's bring it back.
Wait, why are we not?
Because in slant asymptotes we don't need it.
wait, so we're gonna do synthetic division
You use your denominator, set that equal to 0.
oh, that's where you got the 2 from?
Mm-hmm. Okay. We probably have enough now that we could graph this. So let's sketch this. What's my vertical asymptote? 2. And what's my slant asymptote? And y equals x is a line that goes through both of those quadrants. Now, your graph is going to sit inside where the slant is to the vertical axis. Because remember, your asymptotes guide the end behavior. So if you look up here 1 second, you're going to find it in this section, you're going to find it in this section. Sometimes in your calculators, you're only going to see one of them because you're going to have to change your screen. So how do I know? If I see an asymptote thing down here, if I see my asymptote coming through down here, I know it's got to be in the opposite position. This just happens to make your screen. Sometimes it doesn't. This guy is going to come up and go like this. That means this guy has to go like this. The slant asymptote is there to guide the behavior of that end. Make sense? Okay. Makes sense. All right. So this helps us. This also now gives us a max and a min. A is a minimum. Is it absolutely the minimum point on this graph? No, because doesn't this go all the way down here? Right? So what is this called? A relative min. Okay? Find me your relative min. In your calculator, find me your relative min. These appear on your screen. Sometimes they don't. You might have to change your window, but these appear on your screen.
You only have relatively when you use the asymptote.
Because it's making it curve back up. Or 6. What am I going to call B? A relative max. Okay, find me B.
Negative 1.312.
Try it again.
Well, for the y, I got -2.
Negative 2.
Got negative 1.312 for that.
But what does it say? E to the what?
-7.
Oh, so that means you have to move that decimal point 7 positions over. So essentially, what is that going to be?
0.
0. Your calculator does a weird thing. If it gives you negative 1.31 whatever, e to the -7, this is what you have to watch for. That means take this and move this 7 positions over. I got 6 zeros sitting in here. That's
Why does it do
essentially
that?
0. I don't know. It also sometimes with a 2 will give you 2.00001. It'll just do something weird. But your calculator probably will figure something out more exact somewhere. So watch these guys.
So whenever it's
The
an e,
e's.
it's pretty much 7. I mean
It's
0.
0. If it's a negative, it's pretty much 0. Okay, so now we know those. Our x-intercept. Our x-intercept has zeros of the numerator, right? So I'm going to set my numerator equal to 0. And I can't factor this guy. So you can do one of two things. You could complete the square, or you can use your quadratic formula. Now, my rule of thumb is if my leading coefficient is a 1, and my b term is an even number, I like complete the square. If it's not an even number, do the quadratic, because then you're in fractions, you're squaring fractions, you kind of get a little bit nervous, and it comes out better looking with the quadratic formula. So I'm going to complete the square. Plus something, I got a plus 4, and I got a minus something. So what's half of -2? So x minus 1 squared, and what's 1 squared? 1, 1. Now, I subtract 3, I say, uh-oh. If I take the square, sorry, here's my 2. If I take the square root of both sides, I get an imaginary root. All I need you to do is take out the I, the square root of negative 1. So plus or minus I radical 3, and then add your 1. Because did this ever cross the x-axis? No. So it has no real roots. It just has imaginary. If the question says, what are the real roots? You say, no real roots. If the question says, what are the roots? All the roots? Give me the imaginary as well. That's all we do with the imaginary. If you remember back to Algebra 2 or Algebra 1, whenever you learn, when did you learn the imaginary in Algebra 2?
Yeah.
Whenever if you think back, you learned the imaginary because you were doing the quadratic formula and you were stuck. As soon as you did the square root of a negative number, you couldn't go any further. So we took out the imaginary root, the imaginary number, and we completed it the way we always complete it. Okay, y-intercept. Y-intercept is still the same. Go back to the original. Take out the x of 0. Take out that x of 0. So y equals negative 2. 0, negative 2. And you kind of showed me that when you did your relative max. Go back to you're plugging x of 0, so you're taking out these x's. I always like to go back to the original. It's so much easier. Like these we haven't factored, but we only have the original. When you go here and you end up with 4 over negative 2, even after we do the ones with the factoring, go back to the original. It's just easier. So we did everything we needed to do. And now we can do your range. Your range says, I'm looking at my y's. I'm coming all the way up from negative infinity. I have to stop at that y. What's that y? What's my relative max point? Negative 2. So from negative infinity to negative 2. Then I jumped over this nonsense in the middle and I restarted at what point? The y value? 6 to infinity. Okay. You could do your range first. Do your domain first. You can't do your range until you figured out any asymptotes, any other points of discontinuity we'll get to tomorrow. Any of those other extra little things. So since we have something that turns, we have an increasing, decreasing, and we have a concavity still. So let's check your increasing. I'm going to put it over here. Increasing, decreasing. My first time around here, what is my y value doing? Increasing until I hit what x value? 0. Negative infinity to 0. When I hit that x value of 0, what did I do? Decreased. So I decreased from 0 to where? 1. 2. My asymptote is 2, right? So from 0, my x value, from 0 to 2, my y value is decreasing. I can't go past my vertical asymptote. Can't pass the vertical. Then I jump back up here. What's my y value doing? Decreasing from 2 to where? 2 to 4. Okay, that's my min point. And then what am I doing after 4? Increasing. I'm still going off of your max and your mins, but you also have some asymptotes blocking you. And last, concavity. So we have a concave up and we have a concave down. So my concave up says this little piece is going up. Makes a cave up. From where to where? 2 to infinity. My concave down, negative infinity to 2. Good. Shouldn't that also match my domain? But shouldn't they cover my whole domain? And my mins and my maxes should cover my whole domain. Okay. This one had a little bit more going on because we